Greetings, welcome back to Chapter 4, Section 1. In this video, we're going to go over exercises 4.1 and 4.3. So let's go take a look at exercise 4.1, and it says identify the parameter part 1. It says for each of the following scenarios, state whether the parameter of interest would be a mean or a proportion. It may be helpful to examine whether individual responses are numerical or categorical. Okay, so I'm going to scribble on here, but I've already taken this problem, cut and pasted into my R markup file. And so we'll go back and actually put the answers in there also, but I want to do a little bit of scribbling on this page before we do that. So let's go ahead and read what they say. So in a survey, 100 college students were asked how many hours per week they spent on the internet. So notice here that they're asking us for a quantity. This is a numeric value, how many hours. So since we're talking about a quantity here, so which one of these would we be looking for? Well, as it turns out, when you're working with a mean, the parameter for the mean, how did we calculate that? Well, that was equal to the sum of the x divided by the number of samples that we took, right? So it's an average. It's add them all up and divide by the number of numbers. So they have to be numeric to begin with. In other words, the variable x here must be numeric if we're even to consider talking about a mean. If it's a categorical variable, this doesn't make any sense. It doesn't make sense to take eye color. What's blue plus green plus brown divided by 3? I mean, it doesn't make any sense at all. So when you're talking about the mean, we're working with numeric variables. So if you're working with numeric variables, you're talking about the mean. So in this case, in part A, that's going to be the mean. That would be the parameter that we'd be interested in. So we would find an average number of hours. Okay, in one survey, 100 college students were asked what percentage of the time do you spend on the internet as part of your coursework. So what are these people giving you back in part B? What are they reporting to you? They're reporting to you a number, aren't they? A percentage. And you can take those percentages and you can average them, and so you can get back what the average percent is. Now that one's a little bit mean. They were being kind of mean to us here on that one, because usually you think about percentages go with proportions. In fact, we talked about that earlier when we were working with the normal distribution. The percentage, probability, proportion all really mean the same thing. But you're taking and you're averaging the proportions. So you're taking, in a sense, when they say the proportion of time you spend on the internet in a part of your coursework, that is a number. So again, you're going to be looking at the mean here, because it's a number. That's the key thing. So if you're reporting a number, then you're going to be using the mean. If you're reporting a category, then you're going to be reporting back a proportion, okay? In a survey, 100 college students were asked whether or not they cited information from Wikipedia in their papers. So that's a yes/no answer. So in this case, there's only two responses that you could give back: yes or no, true or false, success or failure. Those are categories, and so in that case, what you would be using is the proportion. So we would use the proportion whenever we have categorical variables. That's a no there, really it is. So if you have a categorical variable, you know you're going to use the population proportion. Okay, so they tried to trick us on the first one, but we got on this one already. In a survey, 100 college students are asked what percentage of their totally weekly spending is on alcoholic beverages. So again, it's on a number, so we would use the mean. And then last but not least, in a sample of 100 recent college graduates, it was found that 85% expect to get a job within 1 year of their graduation. Okay, so what are they asking here? This one is kind of, I'm not real happy with part E here, but we'll answer because the book asks us for it. So think about what do they ask it. They ask, do you get a job or do you not? So it's a job or no job. So again, we've got categorical variables, and since we got categorical variables, the tool that we would use here would be the proportion. Okay, I invite you to type these up into RStudio. I'll show you what I did real quick on there. I'm going to go back into my copy of RStudio. Is I came in to make my life easy. I just cut and pasted in there. Okay, so you can just come in here and just put in the answers right at the end. This isn't a survey. 100 college students asked how many hours per week they spend on there. We can type in the mean, right? Okay, etc. So I'll let you guys go ahead and do that. That's not horribly tough. So you come in and just type in the answers. I mean, it's probably harder to cut and paste it than it is to type the answers in there. Okay, let's go take a look at exercise 4.3. So let's go back over to the whiteboard for that. So let's see, I'm going to go down to the next slide. That was a blank slide for me to do some work on. I don't need that. And there we go, exercise 4.3. Okay, so a college counselor is interested in estimating the total or how many credits a student typically enrolls in each semester. The counselor decides to randomly select 100 students by using the registrar's database of students. The histogram below shows the distribution of the number of credits taken by these students. Sample statistics for the distribution are provided. In other words, they did a summary on the data, and they did the SD for us. They calculated the standard deviation. So the thing to realize is that the registrar has all of the data. So they have the population. So the registrar could have given us a parameter, but the counselor is deciding to make an estimate of that parameter. Well, how do we know that? Well, because they took a sample. And so we know that these values right here, in particular, I should point out the values I mean. These values right here, Q1, the median, the mean, the standard deviation, and Q3, those are all statistics. Those are all values that are estimates of population values, okay? And actually, the min and the max are also estimates also, because there obviously could be larger or smaller values in the entire population. So what is the point estimate for the average number of credits taken per semester by students? What about the median? Well, it's really actually very straightforward. We just got to grab these two numbers right off of the list provided to us here. So for the mean, it would be, 13.65? And then for the median, it would be 14. What is the point estimate for the standard deviation for the number of credits taken by the students of this college? What about the interquartile range? Okay, well, for the SD, that's going to be 1.91. The interquartile range is Q3 minus Q1, so that's going to be 15, and subtract from that 13, which is going to be 2. Is a load of 16 credits unusually high at this college? What about 18 credits? Explain your reasoning. Hint, observations further than 2 standard deviations from the mean are usually considered unusual. And in this case, since this appears, I mean, if you take a look at the number of units that the students take, if we got our histogram here, it looks roughly bell-shaped symmetric, if our sample does. And so the 2 standard deviation rule is going to work really nice here, because it could be assumed, I mean, it would not be a bad assumption to assume that this distribution is approximately normal. Okay, so if we're interested in counting number of standard deviations, what is our tool? Well, the tool is going to be equal to z, isn't it? So we take z is equal to x minus mu divided by sigma. Well, we're not going to be able to use mu and sigma here. Why not? Well, because we don't have their values. So instead, what we're going to have to do is we're going to have to calculate z using the point estimates. So z is going to be equal to, instead, it's going to be x minus x bar divided by s. In other words, we're going to use the sample mean and the sample standard deviation. So I'm going to go ahead and do that back over here in RStudio. So if we go into RStudio and we go down to part C here, I'm going to go ahead and insert a chunk. So insert a chunk here, and let's go ahead and do the z-score for both the values that they asked us to do, okay? So they asked us to calculate it for 16 units, and they asked us to calculate it for 18 units, okay? So let's see, what would that be? So for 16 units, we're going to take 16 and then subtract from that what our point estimate of the mean was, which is 13.65. And we'll divide that by our point estimate of the standard deviation, which was 1.91. Okay, and so if we execute that, go ahead and run that chunk, we get back 1.23 standard deviations above the mean. So no, that would not be more than 2 standard deviations. So the load of 16 units would not be unusual. Okay, let's go ahead and do this again. I'm just going to cut and paste here and make my life a little bit easier. Copy and paste, I should say. And so the next one was to ask us about 18 units, right? So to get 18 units, we would come in and just change this and put an 18 in there. Let's go ahead and execute that chunk. And we get 2.27. We could extend our sentence here. Oh, I don't want to use a capital, sorry about that. Unusual. Okay, so 18 units would be unusual because what we saw looking down here is that it's about 2.3 standard deviations above the mean, and typically in a bell-shaped normal distribution, anything that is more than 2 standard deviations above the mean would be considered unusual. Okay, all right, so let's go ahead and scroll down. We can work here. The college counselor takes another random sample of 100 students and this time finds a sample mean of 14.02 units. Should she be surprised that this sample statistic is slightly different from her original one? Explain your reasoning. And you would say what? No, there is, I didn't want to shout the entire answer there, is natural variability in the sample statistic. We would be more surprised. Oh my gosh, I keep bumping the cap lock. Sorry, guys. We would be more surprised if it was the same. And that number doesn't seem all that unusual anyway. 14.02. It was 13.65. That's not very much different, is it really? In fact, if we rounded both of those numbers off to the whole number of units, they both would come out to be 14 units on average to what the students were taking at this particular college. Okay. All right. It says the sample mean gives 1 point estimate for the mean number of credits taken by all students at the college. What measures do we use to quantify the variability of this estimate? Compute this quantity using the data from the original sample. Okay. All right. So the sample mean is more of a statement than anything. This is telling us that the sample mean given is a point estimate. What measures do we use to quantify the variability of this estimate? So we would use the SE of the sample mean. And go back to the whiteboard for a minute on this one so to remind you what that is. So the standard error of the sample mean is given by sigma divided by the square root of n, but we don't have sigma, we have s, we have the sample one, so, but that's okay. All right, so the sample error, excuse me, the standard error is given by sigma divided by the square root of n. Well, if we don't have sigma, then we can estimate sigma using s. So the standard error can be well estimated by s divided by the square root of n. Okay, so It says, what measures do we use to quantify the variability of this estimate? Well, we would use S divided by the square root of n, all right? And so then I tell us to compute this quantity. Well, that quantity is going to be equal to what for us in this particular example? Well, that's the sample standard deviation was 1.91. And we're going to divide that by the square root of n with the square root of 100. So that's going to be equal to 1.91 divided by 10. Or the standard error is going to be given by 0.191. Okay, don't even need R to do that. That's pretty easy arithmetic there. Okay, so I'll let you type up that one. Let's go take a look at question 4.5 now. Okay, so let's go ahead and get into the next one here. Where are we at here? We'll do that over here in RStudio. I think I just copied and pasted that one over into RStudio. So 4.5, we've got wireless routers. John is shopping the wireless routers and is overwhelmed by the number of available options. In order to get a feel for the average price, he takes a sample of 75 routers and finds that the average price for the sample is $75 with a standard deviation of $25. So based on this information, how much variability would he expect to see in the mean prices of repeated samples, each containing 75 randomly selected wireless routers? Okay, so what would he expect there? Well, he knows that the standard error is given by S by the square root of n, right? So if we insert an R chunk here, he can come in and say, well, the standard error is going to be 25 divided by SQRT of 75. Or he would expect about $2.89 would be the variability in all samples of this size. Okay, remember, this is the variability in the averages. That's what we're looking at, not the variability in the parent distribution. Okay, all right. In part B of this particular problem, they say a consumer website claims that the average price of routers is $80. If the true average of $80 is a true average of $80 consistent with John's sample. Okay, well, what they want to know is how many standard errors is the price of $80 away from John's estimate. In other words, did John's estimate work or not, right? So they're saying that $80 is the true average. If that's the true value, then is that consistent with John's sample or not? So is John's X bar, is that, you know, within a reasonable distance of the true population parameter mean? So let's go get a whiteboard for just a minute on this one, okay? So what they're telling us, or what we know from here, is that X bar, our sample that John came up with, was $75, right? And they're telling us that the true population parameter is 80. That's what they meant by that, okay? So they're saying that that's equal to 80, and they want to know, is 75 close to 80 or not? Well, remember that the standard deviation associated with the sampling distribution of X bar is the standard error, and the standard error is given by sigma divided by the square root of n. That's an n right there. And so the z that we want to calculate is going to be equal to X bar minus mu divided by sigma over the square root of n. Now again, this is still just our is no different than any other way we've calculated z before, and that's an n there, by the way. It's simply the observed data point divided by the mean, subtract the mean divided by the standard deviation. It's just the standard deviation this time is given by the standard error. So for our particular case, we're not going to be able to use sigma because we don't know it, but we do have an estimate of this by using s. So we're going to have s divided by the square root of n. Okay, so a good approximation here is going to be X bar minus mu over S divided by the square root of N. And that, provided the sample size is big enough, that works out really well, okay? All right, so how do we actually calculate that? Well, let's go ahead and do it. For our particular problem, that's going to be equal to 80. My bad, got that backwards, didn't I? Sorry about that. That's 75 minus 80. Dyslexia rules this time of the morning, I guess. One more time. Here we go. Okay, so our observed value is 75 minus 80 divided by, well, we said it was 2.89. Let's make our lives easy because we just did that a few minutes ago. So that's 2.89. Okay. All right, so let's go back over into RStudio real quick. And let's go ahead and put that calculation into part B here, and then we can make a decision, all right? So let's go ahead and put in our chunk, and we're going to go parentheses 75 subtract 80 divided by, now if you want, I mean, you can get, uber precise here, open another set of parentheses, and I can just put in 25 divided by SQRT of 75, because remember that's what the standard error was from our previous problem. Okay, so go ahead and run that chunk, and we get negative 1.73, and so that would not be unusual, because we basically say that within 2 standard deviations of the mean is not going to be an unusual event. So no, it does not appear that John's estimate would be unusual. In other words, it's within 2 standard deviations of the mean, so hey, John did a good job of estimating what the true population parameter was. Okay, one more time on chapter 4, you got to read it for me, please. It's going to be real important, and watch the course videos, and please post questions to discussions if you have any questions on any of this.